40 and a half, but I'm a kind of really a nice guy. So I'll go 41. Max, you can get back to 41. So I like whole numbers better than halves. Okay. Oh, wait.
We can get half a point then.
You get half a point, but you still got to take the whole thing. And if you get a worse grade, I'll take the worst grade. So don't do that.
I can't do worse.
For that.
I can't do worse.
Can't do worse?
No, I can't do worse.
Okay, I hope not. I don't know. I've seen it happen. So it could happen. Maybe not with you, but I've seen it happen. For them. So think about it. I do need these back. I'll give them back to you tomorrow to keep, so that you have those to look over. And obviously, this will be on the test. Looking at everything, Marissa's a little disappointed I gave you a test the last day before Thanksgiving, but I really like you guys, and I'm just, I want you to learn. I want you to get better. So that's what that's all about. So some people view it as a negative. I kind of view it as positive.
When's the retake?
Retake either Friday or Monday. Okay, and if it comes down to it, we don't have time, like your full schedule, you can do it during class and then catch up on class later. If you want, we'll just try and work out what's easiest for everybody. Okay. Any other questions over this? I will collect it up in a little bit. All right. Looking at what you put down, a lot of you got it wrong. Some things were minor, some things were major. Let's just take a look at these two, then we'll look at your homework again, or see if you got any questions on your homework.
X squared over X squared. Square root of X squared.
That'd be like a mid-major mistake. That'd be like a mid-major mistake. Not minor, not major, but kind of in between. There should be like an ln in there somewhere too. FYI. Okay. All right. When you are writing in condensed form, you can only have one log or one ln. Okay. You cannot have one on the top or bottom. You cannot have multiple ones. So in the end, it's the natural log of something, and that something has to be in there. So one ln. Okay, when we're done. All right, now let's go through how to get that. And we got to use those properties from yesterday. Yeah, and I did a couple of those problems from the book at the end because there are some common mistakes that creep in. Order of operations is you're going left to right. If you are asked to do 6 minus 12 plus 3, you got to go in what order? What do you got to do first? Yeah, you got to do the minus sign. Addition does not come before subtraction. Never has, never will. Whichever one comes first. So you would say -6 plus 3. You would say -3, right? Because if you do 12 plus 3, you get a different answer. So you got to be careful. So you have to. Where's it at? We got to do this little piece here first. Okay. And actually, before I even get to that, I can do something. What do I do with constants out in front? They become exponents. Constants out in front become exponents. So this 2 only goes with the natural log of x, so it's natural log of x squared. 1/2 becomes power, natural log of x squared plus 5 to the 1/2 power, and then this 3 becomes a power on that. And at no point should you have to take that to the power. You don't have to do x plus 3 cubed. You don't have to try and do x squared plus 5 to the 1/2. Just leave it. The 1/2 is what power. And in the end, I don't want this power because what does the 1/2 become? Square root. And now I want to do this here. Minus means what? If we're subtracting 2 things with logs, we can write it as a division problem. So this becomes natural log of, now it's just a single natural log. You divide x squared over, and I'm going to make this the square root of x squared plus 5. So at some point I got to make it the square root. Plus natural log of x plus 3 cubed. Okay, so we got that. Now, what do I do if there's a plus and I get 2 things I'm taking log of? I can now multiply them. So I'm going to have the natural log of x squared over square root of x squared plus 5 times x plus 3 cubed. Okay, for that. So you can think about that. Now, the only thing I'm going to do is I'm not going to accept that as an answer because you can simplify this. I need a single numerator and a single denominator. Okay, so don't leave, two things being multiplied together. Merge those two together. And then this is just going to be a natural log of x squared times x plus 3 cubed. That has to go in the numerator over square root of x squared plus 5. Okay. All right, now, who got that exactly right? Ooh, 3? 3, 4. Okay, so fix your mistakes. So if you missed it, you're not alone. If you missed it, you're not alone. But you got to be able to get this correct as we move forward. Now, so I saw, like I said, a lot of little different things. One ln. A lot of times people have an ln on top and ln on bottom. Can't do that. All right, now, going from condensed to expanded form. A couple of key things I said yesterday. I said you cannot have any products, you cannot have any quotients, you cannot have any powers within your final answer. So all that has to be gone. We're going to go backwards. So we got a division problem. You got a division problem, you can make it what? Subtraction. So this becomes log of x cubed times the square root of z minus the log of y squared. Okay, do I still have a product here? Or do I have a product here? Yep, split it apart. Make it a sum. So that becomes the log of x cubed plus the log, and I'm going to make this z to the 1/2 minus log of y squared. So the square root becomes the power of 1/2. And now I have powers. The powers become constants or coefficients in front. So now this becomes 3 times the log of x plus 1/2 times the log of z minus 2 log of y. And the thing is that you always got to look, say, all right, can I do anything else? Sometimes that can be a little bit confusing because sometimes you want to do more than you are, or you think you're done, and there's still another step. So you take a look at what's after the log. Log of x. Okay, there's no power, no product, no quotient. Log of z, log of y. No product, no power, quotient. So we're done. Okay, you got the coefficients out in front. So just be careful on those. Homework-wise, now 16 was the only one that was even. And then 125, I still wanted to put these down anyway, just to make sure you actually check what you have. Because some of these are difficult, I guess. Make sure you figure out what's going on and understand it. I at least want to look at, I believe it is H. And I think that says the natural log of 1 over x equals negative natural log of x. It's true. Now you need to tell me why, though. Why is that true? Or go through a couple steps to show me that's true.
X to the negative first would be equivalent to 1 over x. So then if you were to put the exponent in the front, it would be -1, or you just make it negative.
All right, very good. 1 over x is the same thing as x to the negative first. So instead of going from a negative exponent to 1 over x, we're going to go backwards. That is an exponent. Anytime you have an exponent, it becomes a what? Constant out in front. So that becomes -1 or just negative natural log of x. So that's how you can do that. I can go backwards here. If you got a negative in front, that's like a -1. That can become an exponent. So that could become an x to the negative first. Well, x to the negative first is the same as 1 over x. So you can either start on the left and go to the right, or start on the right or go to the left, but those have to be equal. Okay. All right, what other questions you got on those homework ones?
51.
51. All right, let's see here. 51. One half log of x minus log of y plus log of z. And we want to come up with that. All right, now 1/2 becomes square root. Log square root of x minus log of y plus log of z. Okay, we have to, since it's just subtraction and addition, we do what comes first, we subtract, which means we write it as a what type of problem? From subtraction, it goes to a division. So I'm dividing in only one log of square root of x over y. All right, there is a huge temptation to do this. Okay, that is not correct. Okay, that is a different value. That is incorrect. You have to write it as the log of just radical x over y. Okay, do not do log over log. Now, plus log of z. Since it's a plus, I can multiply whatever I'm taking the logs of, square root of x over y, times z. Now, here's the only thing I'm saying. You can't leave it like that. You got to simplify it to a single numerator, single denominator. So what does this become? This becomes log of square root of x times z over y. Okay, before that. A lot of times people want to do this first, and you either put them both underneath or that's just a temptation. That would be your answer. Log square root of x over z divided by y. Okay. What else?
You go for 16.
16. Yes. 16. What'd you get?
Not 11.
Not 11?
No.
Okay, so let's see here. What's the original problem?
Log of x times y, and then y to the third power.
Okay, that?
Yeah.
Okay, and now log of x, is that equal to 2?
Mm-hmm.
And log of y equals 3, correct? Yes, okay. You can't plug in just the log of x. Do we have the log of x by itself? Nope, got to get it by itself. Do we have the log of y by itself? Nope, can't substitute in. So we got to do our properties. This is a product, split it apart, which means we write it as a sum. So this becomes log of x plus log of y to the third. All right, I got log of x by itself. Good, that's good. Not yet over here. I got to take this 3, put it out in front. So now I got log of x, I got log of y. I can replace log of x is 2, log of y is 3, but you're multiplying it by that 3 in front. 3 times 3 is 9, 9 plus 2 gives me 11. All right, so good. All right. What else? All right. Nothing? Okay. All right, again, I don't know why I keep saying this, but check your answers. Okay. Make sure you're getting it right, because these, like, this is the format, like, how should the answer look? That's helpful to kind of see that. All right, we got to finish up those guided notes. We didn't get to that last page. Got to talk about half-life, which I'm way past my half-life at this point, but we can figure out the half-life and some other things. Okay, and we got some exponential growth and decay. Some good stuff. If we got any future paleontologists, you can figure out how old the fossils are you are finding with some radiocarbon or some carbon dating. Exponent. We already seen this equation. Okay, we got E. Okay, because we got an exponential growth or we got an exponential decay. The growth formula is the following: A of t, where that is whatever the amount of time t, and then A sub 0 is the initial amount or the amount of time equals 0. We usually don't know k. You usually got to figure out k, or they'll give you enough information to do that. So for this first case here, we got an experiment. 18 grams of the radioactive element sodium 24 decayed to 6 grams in 24 hours. Find its half-life to the nearest hour. Okay, find its half-life to the nearest hour. All right, we're going to have to find K first. Okay, we're going to have to figure out what K is. Start with that formula. A of T equals A sub 0 e to the KT. So we want to find K. Let's see here. All right, they give us a situation. 6 grams, 18 reduced to 6 in 24 hours. So at T equals 24, I have 6 grams left. So 6 goes where A of T is. My initial amount is 18. And then I got E to the K times 24 because it's 24 hours. Now I'll flip it around and write 24K here in a second. But we're going to start with that. We need to get K by itself. K equals. Divide by 18. You cannot subtract 18 because those are being multiplied. That is 1/3 equals E times 24K. Now for this problem, I'm going to keep K in its exact form, which you'll see in a second. I'm not going to get the decimal until the very end. All right, this is like some of the problems we did on the last quiz. Convert that to natural log form. Mr. Buckerfield, how we doing? Come on in.
Matt Sign's not here.
No, he's not. 3 days in a row. We're going to put an APB out for him.
I couldn't remember if he was in second. I did just mark him.
Oh, he didn't work him out. Sorry, it's bad.
About to.
You're about to get the call.
Yeah, I'm going to get the call.
Yeah.
Yikes.
Way to know your students.
Yeah.
All right. What do we got? Anthony, what's that in ln for? Natural. Good. Natural log of 1/3 equals 24K. And so divide by 24. Divide by 24. Divide by 24. I get K equals the natural log of 1/3 over 24. Yes, you can type that in calculate. Get your big, long, messy decimal. I'm just going to keep it like that. That's my K value. Okay. So I'm going to go up here. K equals natural log 1/3 over 24. All right, how do I find the half-life now? Okay, what you got, Andrew?
I'm using the half-life formula.
What's that?
H equals negative natural log of 2 divided by K.
Okay, so you're sneaking on to my next slide, which is, so H equals what? Negative natural log of 2 divided by K. All right, so you're going to see this, and we're going to come close to that. What? And yes, you can. If you know it, you can use it. Absolutely fine. But let's say you forget it, which I've done this for a while. 95% of you will forget that. Okay, you can still find the half-life. How are we going to do that? Well, it started with how many grams?
18.
18. We just need to figure out when there's how many left.
6.
No, we already know that. 9. We want when half of it is left. So we started with 18. We want to know when there's 9 left. And I'm not going to put in that whole K till the end. I know what it is, but it's just too messy to write. Divide by 18. Now this is always going to be the case. If you're going to find the half-life, this is going to be 1/2. Okay, you want to know when half is left. E to the KT. Again, we go back to convert it to natural log form. Anthony, you did it right the first time. What's natural log form?
Natural log 0.5 equals K times T.
He said natural log of 0.5 or 1/2 equals K times T. We know what K is, so I divide by K. So I get T equals natural log of 1/2 divided by K. Now T is going to be my half-life. Now over here, Andrew was using his ingenuity. You're going to have to explain to me why those are different. We'll do that in a second, but that's fine. It's gonna end up being the same. Now, what is K? What did we write up above? T equals natural log of a half over K, which was natural log of a third, right? Divided by 24. All right, so you just got to be careful there. Nearest hour. Go ahead and use your calculator. Yep, there you go. What's it? 15. Get 15. Mackenzie, get 15?
Yeah.
15. So T equals 15 hours. T equals 15 hours. Hours. All right, now. All right, over here, they give you this little half-life formula. If you know what K is, you can figure out. Now, we just said we got H equals natural log of 1/2 over K. That's how we ended up with, right? How are these the same? They are the same. They are the same because 1/2, how can you write that with an exponent? That's really 2 to what power? 2 to the what? -1. So it's natural log of 2 to the -1. And what do we do with that -1? Put it out in front. So if you remember this formula, absolutely you can use it. Just plug it in. If you don't remember this formula, you can still find out everything you need. Okay, so 9 divided by 18, you just set it up and figure out the half-life. It all works out in the wash. So there is that case there. All right, let's take a look at that last one. I give you the half-life, and you could use that to figure out K. We're still gonna have to find K at some point. What do we got here? Plutonium. Ooh, little plutonium. Well, it might be from a Bond episode, I think. Plutonium 241 has a half-life of 13 years. If you originally had 80 grams, how much would remain after 18 years? Okay, so same idea, A of T equals A sub 0 e to the KT. We're gonna find K. We're gonna find it. I don't know what it is. I do know that when T is 13, I got half of it left, right? So after 13 years, my 80 grams will turn to 40, and then this will become 13K, or my T is 13, right? Divide by 40 or divide by 80, and then what do we get over here? Divide by 80, and we get 1/2 equals e to the 13K. Natural log of 1/2 equals 13K. Divide by 13. And then K equals natural log of 1/2 over 13, or K equals negative natural log of 2 over 13. I don't really care how you write it. All right, so you can figure out the rest. How much time, or no, how much will be left after 18 years? Okay, so we know what K is now. We know what K is. All right, see what you come up with. Nearest tenth is fine. Nearest tenth is fine. I don't think it's specified. So after 18 years, we're going to let T equal 18. All right, for that one. Aiden, you got an answer?
No.
No? Are you stuck or are you just still working?
Yes, I'm stuck.
You're stuck. Mud. Go back to our original equation. This one right here. Basically, we're just plugging in T equals 18. Because we want to know what after 18 years is. What's my original amount? That hasn't changed. That's still what? 80. We know what K is. Okay, so now basically you're saying a of 18, or you can just put a equals 80 e times k, which is natural log of 1/2 divided by 13 times t, which is 18. So now you just got to input problem 80 e to the, let's see, what am I going to have to do? I'm going to make it ln of 0.5 divided by 13. Wait. Yeah, that'll work, right? Times 18. 30.6? Yes. So my amount will be 30.6 grams. 18 years is after its half-life, so you should have less than half. And you should be able to gauge whether it's reasonable. Okay, where that value is reasonable. All right, we're going to start in the next section. If you want to put it on the back of this sheet, that's fine. Or if you want to start a new page of notes, that is fine. But we are going to move into 4.4. Solve an exponential equation, solve a log equation. So kind of today, tomorrow is what, Thursday? And then a little bit of Friday. So we'll review a little bit of Friday, a little bit of Monday. Okay? Because I don't want you to have any work over Thanksgiving. So, I really want you to enjoy your holiday.
Can you go back? I'm really confused on how you got that answer.
Where'd you get confused at?
Like, I found K, but I don't know how to plug it in to get your answer. Every time I plugged it, I got negative 1.1.
So into the calculator? All right, I'm debating on just looking at yours. Did you see how I entered it?
Yeah. I did the same way. I just got a different answer.
Can't have it. So let me see what you got. And then I'll see if it needs to be. Write that equation down. All right. This is good.
I don't think it's right.
You put 29.
So isn't that what you get when you get 27 plus 2?
Well, yeah, but once you add it up.
Oh, you're right.
I put it in my form.
Alright, let's look at it. So, yeah, we got something wrong. Yeah, I'm not sure. Alright, did you get an answer?
Yeah.
3.5? Alright, now I'm going to do this two ways. First thing is when you have an exponential function, I'm I'm gonna look to see, can I put them in the same base? Can I convert it to the same base? So 9 can be written as what?
3 to the 3rd.
Not 9.
Third.
3 what? Squared.
Squared.
9 is 3 squared, and 27 is 3 cubed. This is a power to a power, so that becomes 2x minus 4 equals 3 to the 3rd power. And now once you get bases the same, those have to be the same. So now you can say 2x minus 4 has to equal 3. Add 4, 2x equals 7. Divide by 2, x equals 7 halves. Okay. I know some of you did a little bit different. Got that answer correct, that's fine. But that's how you get 3.5 or 7 halves. Convert it to the same base. Not everything will work that way. Try it if it will. This next one, you can convert to the same base. Think about that. 8 to the x minus 3 equals 16 to the x. So think about that. If you know it, convert it. If not, just hold on a second. Has it been screwing up on anything else, Andrew, or is it just...
It didn't work on the other problem either, or above it.
All right. 8 to the 3rd power to the x minus 3. 16 to the 4th power to the x. Don't forget that x is still part of that. These multiply. 2 to 3x minus 9 equals 2 to the 4x. Same base. 3x minus 9 equals 4x. Subtract 3x. And then I get negative 9 equals x. X equals negative 9. Okay, so you get that. Now you eventually run into a problem. Not everything can be written in the same base. But you gotta make sure you don't make a mistake. 4 to the x equals 100. Can they be written in the same base? 4 can be written as 2 squared. You cannot take 2 to a power and get 100. And you can't make it 10 squared because you got different bases. So we're stuck. This is where logs come into play. Okay, this is where logs are very, very useful. 4 to the x equals 100. As long as you do the same thing to both sides of the equation, it maintains its equality. Take the log of both sides. You can technically do it to any base. We're going to either do base 10 or natural log just because that's on our calculator. What I mean by that is I'm going to write the log of 4 to the x equals the log of 100. It's really base 10. I'm not writing the base because we don't write it for base 10. Why does this work? Because when you have a log, remember our properties, what do we do to the exponent? Bring it where? Bring it to the front. It becomes a coefficient. So this now becomes x times log of 4 equals log of 100. Okay. X times log of 4 equals log of 100. I want to get x by itself. What do? Divide by log of 4. Log of 4 is a number. Log of 4 is a number. Okay, now, Andrew, I'm most interested to see if this gives you the same answer. So we're going to do log of 100. Log of 100 divided by log of 4. We're going to go to 3 decimal places. It said it earlier on. Whenever we need to. 3.322. 3.322. Andrew, did you get that?
Yeah.
Yeah? All right, so that's encouraging. Now, I said you could use any base. Let me just run through this real quick. 4 to the x equals 100. You can make it natural log of 4 to the x equals natural log of 100. What do we do with the x? Put it out in front. X times natural log of 4 equals natural log of 100. Divide by natural log of 4. Divide by natural log of 4. And so you get, now again, since yours was not working for natural logs, double check this one. natural log of 100 divided by natural log of 4. I get the same thing. Yeah, but you do need to understand one thing. These are really not the exact same if you look at it. The log of 100. Is the log of 100 the same as the natural log of 100? Should it be the same? Shouldn't, because one is 10 to what power equals 100. What should this equal?
10.
Not 10.
2.
2. Because 10 squared is 100. What's the ln of 100 equal? E to what power equals 100? I don't know, but 4.6 something. Okay, but understand they're not exactly the same. Okay, they give you the same answer, but in terms of that work. Did natural log of 100 over natural log of 4 work? All right, we're typing something in wrong. All right, let's do. Wait. We're going to stop there. We're going to stop there. Okay, I am going to give you a couple problems. Let's see here. I do want you to do all of these. These are the ones with the half-life. And then we'll just do a couple off of that page 484. We'll finish up, or we'll keep working through. There's some different type of equations that we're going to run into that we need to make sure we get some examples of. So just those 4, and then those 2 from 484. All right, that'll be it. Let me check that.
Why on the last one did you just convert it from like exponential log form to do it?
So you write
Like,
that.
why didn't you just
Oh,
do
you
log
can
of-
do that.
Okay.
Okay, so as we do that, let's take a look. Hold on.
Yeah, I was like,
Do you want the quizzes back?
Yes, I need the quizzes back. Let me come get those. One of the reasons is